All right, ladies and gentlemen, this is pre-algebra lesson 4 dash, oh, not 5. Nope. We are going to do 4-7 today. Okay? 4-7. This lesson covers how to use similar figures to solve problems. And so today we're going to do a lot of drawing. Most of what we're doing today is based on drawing triangles. So we'll go ahead and get started. Please, in your notes, draw a very large triangle. Make it a right triangle, like that. On this triangle, we're going to add a few things. I'm going to start by labeling the points. We're going to call this point down here on the bottom left A. We'll call the point in the upper right B, and the point at the right angle point C. We are also going to draw a tree. Okay, there's the top of the tree. And here is going to be the bottom of the tree. Okay, there's our tree. The whole point of this lesson today is to find the height of the tree. Now, we don't have just a tree. We are also going to include a person. So down here we are going to have okay, maybe those legs are a little long for that guy. Okay, there we are. We've got a person, we've got a tree. It's kind of a weird person, nonetheless. Maybe we'll do something like this. All right. I'm going to tell you right now that this person is a height, or has a height, of 6 feet. And I'm also going to tell you that the person from point A is a distance of 10 feet. Okay, so from point A to the person is 10 feet. That's what we have so far. I also have been able to measure, okay, from the person to the tree. And I have found that the distance from the person to the center of the trunk of the tree is 55 feet. So that's what we have so far. I should let you know that when you measure something, in mathematics we call, like with a tape measure. Okay, so you take a ruler or a tape measure or a meter stick and you walk up to something and you measure it. Or you measure an angle with a protractor. Or you measure the temperature. When you can physically measure something directly, we call that direct measurement. These 3 measurements are direct measurements. However, unfortunately, there are times when we cannot measure everything directly, whether we are limited by our tools, we're limited by our ability to literally get to the object. And so in that situation, we rely on math to solve the problem for us, to find the measurement. So when we use math to find a measurement in a roundabout sort of way, we call that indirect measurement. And I'm going to tell you that the height of the tree, okay, which we are going to call h, will be an indirect measurement. We'll just call it an indirect measure for short, because we're going to use math to find the height. All right. Now, looking at this, I have what appears to be a small triangle right here. Okay? And I also have a large triangle right here. I can use what I know about proportions between similar figures to solve for the height of the tree. So, what I recommend you do when you see a problem like this in your homework, which you will, is that you redraw the images separately. Okay, so I'm going to go ahead and create a new page, and I'm going to draw two similar triangles, one larger, let's go, and one smaller. They don't have to be exactly the same shape as the original because we're just using them to make a comparison. You don't need to. No, we've already got the original image, which will be like in your text. You'll see pictures in your text. It's the important part is figuring out how to draw the images differently on your paper. And so you'll see an image like this, and what I want to do is pull it out. Okay, I'm going to label the large one ABC like it is here, but I need to give some new letters to my little triangle. So I'm going to call this D, and I'm going to call this E. Okay, so A, D, E. So I'm going to label this A, D, E. All right, I'm going to leave this up on the screen. You have the triangles in your notes. What is the distance between A and E? Okay, so that would be the distance between point A and the person. Isaiah? Okay, it's 10 feet, so I'm going to put a 10 here. Okay, is there any other distances I can pull out and add to my pictures here? Casey? Okay, so the distance between D and E is 6 feet. Very good. Okay, so I can definitely do that. Are there any others I can pull out? Yeah, Casey? Okay, and what's the distance between A and C? All right, 65 feet. You have to add the two measurements from the original picture. Okay, if you go back, let me point it out to you. You have to add this and that. Okay. I want to find H, which is the distance between B and C. Okay. Is there any proportion I can set up that would help me solve this? Casey? Okay, so I can start with 65 over 10. Very good. And that would be equal to what proportion? I made a comparison between my large triangle and my small one. So let's make a same comparison between the large and the small. Dylan? Yeah. It's going to be H over 6. So I'm making comparisons between my large triangle measurements in the top and my small triangle measurements in the bottom. Okay, so let's cross multiply, or find the cross product. H times 10 is 10H, and that's going to be equal to 65 times 6, which is what? 390. Okay, how do I get H by itself, ladies and gentlemen? How do I do that? Yeah, Kennedy? I divide 390 by 10, and you're right. I will have the 10s cancel on the left-hand side. I will be left with an H, and that's going to be equal to, and if you can look here, you don't even really need to do this on a calculator. The zeros at the end cancel, and you're left with what number? 39. And so the height of the tree, based on our measurements, is going to be 39 feet. So we can put this over here. It'd be 39 feet. Okay, so this is how we use similar figures to solve for the height of an object. All right, I will give you another example. This one's a little different. Okay, this one's a little different. Draw this one as well. We are going to draw a pond. Actually, it's probably going to be more like a lake. Okay, it's a lake. And here's what's happening with the lake. There is a person that's stuck on the far side of the lake. Okay? Okay? So they're stuck on the far side of the lake. They want to get to their cabin or their cottage, which is over here. However, it's going to take too long to walk around the lake. So they've got a boat. So they have a boat that is going to take them across the lake to the cabin. However, they need assistance. The lake is too far to see the other side. And so they have to rely on a local radar station to assist in the passage across the lake. And so the radar station is actually located. Might be making it up.
Is that another boat? Did you use it from the city?
Yeah, but I made it up.
Oh, that.
All right, so there's a radar station here, and they're going to radio in. The problem is they don't necessarily know at first how far it is across the lake. And so what they have to do is they have to decide whether or not he can make it. Because he only has fuel enough to go 10 miles. Okay? Well, sailboats sometimes have engines, okay? And so he only has enough fuel to go 10 miles. So the question we have to decide is, can he make it across the lake? Or otherwise, does he have to pull a Bear Grylls and brave the elements? Okay? So, all right. Now, what I will tell you is that there are a couple reference objects in this problem. Ladies and gentlemen, the reference objects are, based on this radio tower, they have a small building on the property, which we are going to draw as a cube. Here. And there's also a parking lot here. There's a parking lot here. The cube is just a random building on the property. And there's a parking lot here as well. Okay? And so what the radar station does is they pull out a map, and they start drawing some lines for reference. They say, well, we know that we can probably get a line here, and we can extend that line all the way to the person. So we can kind of see that they kind of connect there. We also see that if we draw a line between the parking lot and the radar station, we could extend that same line all the way up here to the cabin. And then if we draw a line here, okay, we have something going on here. And so what happens is there actually forms two similar triangles. We have a small triangle here that is similar to a larger triangle right here. Now, I only know a few measurements. I do not know the distance across the lake, which we will call Z. Okay, we will call that Z, the distance across the lake. I do know the distance from the cube to the radar station is 1/2 mile. I know the distance from the radar station to the person is 3 miles. And I know the distance between the outbuilding, or what we call the cube building, and the parking lot is 2 miles. Okay, so this is what we could say you'd be given in a problem. Yeah, Liam.
Can the cube thing be an outhouse?
Sure. Put a little crescent moon in the door there. Maybe even a little window. Okay, that's a fancy one.
Okay, it's basically only 3 miles to the solar thing. So why can't you just walk?
Okay, well,
He's being so difficult.
It'd only be like 6
you know,
miles.
it's a direct measurement. He went around the lake. He never knows. There's lions, tigers, bears. Oh my! You just never know.
Where's this lake at?
Well, this lake is in. Hey, it's in Oz. Thanks. There's flying monkeys. They have radars everywhere. Are you kidding?
I remember seeing that radar in the movie.
I never saw an outhouse either.
Well, what's he doing?
I've seen one.
All right. So, ladies and gentlemen, I'm going to redraw this as the triangles that we're working with. Okay. I'm going to show you the original image. Okay, like so. You should know that the following proportions work. Let me label these. A, B, or excuse me, let me not do that. A, B, C, X, Y, Z. I will tell you that the following sides are proportional. A is proportional to X. B is proportional to Y, and C is proportional to Z. Looking at your original picture, I'm not going to go back there, which ones do we know? Which of A, B, C, X, Y, Z, which numbers do we know? Dylan. Okay, what is X?
X is 3.
Okay, so we know that X equals 3.
So A must equal 3.
No, they're proportional, not equal. Okay, what else do we know? Kennedy? Okay, A equals a half. I'm going to write it as 0.5. What else do we know? What else do we know? Casey? Okay, C equals 2. And what are we trying to find? Trying to find Z. Which proportion do I not need to worry about in this particular example? David?
B and Y.
Yeah, B over Y is not necessary for this particular example. So I'm just going to go ahead and scratch it out. Now, I can set two proportions equal to each other and solve. Because they're similar figures, I can, oh my goodness. Okay, so here we go. Let's set these equal to each other. I know that A over X can equal C over Z. I'm comparing small triangle to large triangle. If I plug in the new numbers, I know that I have the following proportion to work with. 0.5 over 3 equals 2 over Z. So I can go ahead and do what to solve this? Did I hear square root? Square root is not an option here, but I can find the cross product or cross multiply. So I'm going to go ahead and do that. 2 times 3 is 6, and that's going to be equal to 1/2 Z, or 0.5 times Z.
I thought it was 0.5.
Okay, what
Okay,
even?
it doesn't matter.
Okay,
Wait, what was the answer?
0.5 Z.
now, how would I get Z by itself? Liam?
You draw the line thingy, and then 0.5. Yeah.
One side?
Both.
I have to do it on both.
And
Now over here on the right-hand side, what's going to happen?
Cross each other out.
You divide it. Wait, right
What
hand
is
side. It
this?
cancels.
They cancel.
Cancels out.
And 6 divided by 1/2 is, Dylan? 12.
So you can't make it across.
Oh, very good. Drew, you're right. It takes 12 miles to go across, so he has two options. He might have to walk around the lake,
Or he'll die.
or, which is longer, or he can use the engine to get 10 miles across and then paddle with his hands 2 miles.
Or he can pray to God
He can boat all the
that
way
he
to
can walk on
where
water.
the radio station is, then just walk.
He could boat to the radio station and then walk?
Yeah.
Yeah.
Oh, so there's some options here.
Why?
He could go 3 and 3.
Man, yeah, there's a lot of things he could do.
No, he could
He's
go
just
3.
slow. He shouldn't be in the wilderness.
Yeah.
All right.
He's one of those guys for.
He's slow,
He's not good for the
not
wilderness.
fit for the wilderness.